Here, I'll go ahead. Here. No, I'm not. Ha. I'm not ready. So, section 9.2 understandably is talking about math you might teach if you have a middle school assignment or something, or like that. This is pre-algebra kind of stuff. This is even before pre-algebra. So this is like 6th, 7th, 8th, 9th grade in there. This is stuff like, for example, the only kind of numbers, and if I remember correctly, I think I sort of got a little bit into this before. The only kind of numbers we haven't directly talked about yet, we talked about positive whole numbers, 0, 1, 2, 3. Then we added the integers in. Then we added the fractions in. And I think the last thing I did last time was we said, somebody could say, well, what's between 3/7 and 4/7? And there's an infinite number of things between them. But if you only put the fractions there, you're still missing an infinite number of numbers. So what kind of numbers cannot be expressed as fractions? Well, I mean, fractions are decimals, are they? Like 1/2 is 0.5. So any decimal that does not stop or repeat. You guys, there we go. There we go. We're almost there. I need you to understand. Today's the last new stuff. With me. Today is next Tuesday is review for the final. Next Thursday is the final, which is insane. I can't remember the last time we ended a semester this early. Next week is it. You guys all know. Yeah, you're all like so much. Okay. So stay with me now. We're almost there. So last time I talked about the fact you have a number line. If you put a couple of decimals down here, you might have a student that says, okay, what's between those two? And we talked about how you can find something between those two, right? 1 plus 2 over 3 plus 3 is 3/6 is 1/2, so 1/2 is between. And I can keep going forever doing that, couldn't I? The funky thing is, that's an infinite number of fractions. That still leaves infinite little gaps on the number line. So, why is this a fraction? That is currently in decimal form, but that is a fraction that is currently in decimal form. Why is that a fraction? Because it ends. It determines. It stops. I don't care how many places there are. If I stop, can somebody remind me of the little shortcut I gave you guys? How many zeros are going to be on the bottom of that fraction? 3, because there's 3 decimal places. So if I had a decimal that had 87 billion decimal places, it's just the number over 1 followed by 87 billion zeros. It's a fraction. It's a funky ass fraction, but it's a fraction. So how do I create a number that would not become a fraction? I just make a number that does not repeat. Blah, 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 blah. There's no repetition indicated. Yes? The little dots don't mean there's a pattern set up. I didn't put little bars over anything. There's no pattern. The simplest, so that's one example I just made up. So there is no fraction representation for that. Can you guys remember from earlier today? What's another way to describe this type of thing? It's a fraction, but what else is it? It's a what of 2 numbers? It's a ratio. So we call numbers that could be represented as fractions, we call them rational numbers. Because math people are so creative.
Oh, yeah, it's ratios. Oh, rational.
So numbers that cannot be represented as fractions are called irrational. You already know an irrational number has to deal with circles. What number deals with circles? That's irrational, so we gave it a symbol instead of writing out infinite number of decimal places. Pi. Yes? So pi, you all know pi. Pi is not 3.14. pi is 3.141596, blah, blah, blah. That's as far as I got. Goes forever. No pattern that we know of. Yes? That is irrational. This is irrational. Pi is irrational. Square root of 2 is irrational. You cannot represent the square root of 2 as a ratio of two whole numbers. You can't. You can't represent pi as a ratio of two whole numbers. You can't represent that funky little decimal I made up as a ratio of two whole numbers. Are you guys at all with me? Okay. So this naturally opens up an exploration into radicals. This is the first time this semester we've actually directly looked at, I've brought up square roots before, but we haven't looked directly at radicals. In fact, is everybody cool when I say radical? You all understand I'm not trying to be 90s hip or something.
That's right.
What does radical represent? What does it mean? Does anyone know how radical is related to square roots and so forth? Does anyone know? Have you guys heard the term before mathematically? Does anyone know what it represents, or have you just sat there and went, sure? Okay. Can you guys all please write down square root of 3? That symbol you use, that the 3 is inside, that is a radical. So very often you'll hear funky ass math people say that's rad 3. Just a quick way to say it. So square root of 3, we're lazy. We don't want to even speak that much. So we say square root of 3. We say radical. Yeah, I guess. So that's the radical symbol. That's why very often I'll interchange the word radical with like roots, square roots, cube roots. Now what the shit is a square root? What the shit is a cube root? What is this question here asking you for? Why is this one is not irrational? What is that asking you? Well, what is the square root of 16? How do you know? Yeah, so what question does that symbol ask you? Yeah, what number times itself makes 16? Or what number needs a second power to become 16? You guys with me? You guys with me? That's why the square root of 3 is funky as shit. Can you come up with a number that when you multiply it by itself, you get 3? Not 1 times 3. It's a number that when you multiply it by itself, you see? You understand? Yes? I think it's 1.75. That's just because I have it sort of memorized, but I'm not even sure. What is the square root of 3? Can somebody do it on your calculator? Let's see how close math boy got. 1.73. Yes? Yeah. Okay. Thanks, Lauren. Lauren's like, good job. All right. Are you guys, you all have done square roots before. I know it. You all know what the square root of 16 is. The reason that you don't have to stop and think about that symbol is because you've already internalized the question it asks. Have you guys ever done logarithms? All right. People hate them. We're not going to do them. Don't freak out. People hate logarithms because dumbass math people said, let's use the word log as the symbol, and that trips people up to shit. And then you got trig, sine, and cosine, forget about it. Square root is just a symbol. We can live with that, and we internalize the question it asks. What does it take to roughly multiply by 16? Yes? So, can you do it, Jeff? Maybe. I don't know if you can do it. What about if I ask you, well, here, this is 4. What's the cube root of 8? What does that mean now? What question is that asking you that's different? Yes, what does it take 3 of to multiply to be 8? So it's got to be a number multiplied by itself in a string of 3, yes? What number does that? 2. 2 times 2 is 4, times 2 is 8. You guys with me? So these 2 examples are rational because they become whole numbers, yes? Anything you cannot do the root of directly is irrational. If I said, what's the cube root of 7? Why can you not tell me that answer directly? You can't give me the exact answer. Can somebody estimate it? Can somebody estimate it? You can do it, you can do it. We know the cube root of 8 is 2. So give me an estimate for the cube root of 7. Yes? Yeah, I'd say 1.9, 1.8, something like that. Because 7 is really close to 8, so the cube root should be really close to 2. Are you guys all with me? But whatever the shit the cube root of 7 is, it is a decimal that never ends, has no repetition. So either roots work and they're nice whole numbers, or they don't work and they're funky ass irrational numbers. Okay. I like it. I don't know. Okay. So let me ask you this. Could you come up with a process then to figure out what is, Jeff? What this is. No, let me pick a better one. Hold on. Oh. Yeah, okay, this is perfect. I tell you, there's an answer to that. There's a nice answer. There's a nice whole number answer to that problem. Can you figure out how to get it? What is that asking you for? What number does it take 3 of to multiply by 343? Can you guys come up with a way to get it? I'm open, I'm wide open. If you have a cube root button, I don't want to hear that shit. I want a different way than a cube root button. How could you figure that out? You can do it, come on. Is the answer 5? How could you check to see if the answer is 5? How would you check to see if the answer is 5? Huh? 5 times 5? Times 5. What's 5 times 5 times 5? 100. No. Yes. 25 times 5 is 20 times 5 plus 5 times 5. So it's 100 plus 25. 125, which is this.
There you go.
The road we live in. You guys with me? The road that the Grawlers lives near. Yes.
Would it be 11? Because, like, I don't know. I don't remember the rule
Oh.
for it, but.
Yeah, it sort of has a pattern that you think 11 because 11 times 11 is 121.
Mm-hmm.
So 1, 2, 1, but no. Yes.
If you divide it by 3, does that, well, you get 114, so does that mean that, wait a minute,
Yeah. You need 3, not 3 numbers that add to be 343. 3 numbers that multiply. So listen, guys, keep going. Is it 6? Is 6 the answer?
Maybe.
How do you check? Do it. What's 6 times 6 times 6? Some of you guys gave me back your calculator. That's okay. Let's do that. So is that the answer? But you see how we're getting closer, yeah? 125, 216. What's 7 times 7 times 7? Holy shit. So what's the cube root of 343? 7. Because 7 cubed is 343. You guys with me? Okay. So even if I gave you a problem where it's not something you just know, like the square root of 16, you guys barely have to think about that. This one you have to know what the thing wants from you and come up with a plan to get it. And that to me is the easiest plan, right? Just take a guess. 5. Let's check. Nope. Needs to be higher. 6. All right. Nope. Needs to be higher. 7. Okay, then you got it. Now we get into some really, really funky stuff. What is happening? It's like a weird flash mob. All right. So, what can you guys explain this to me? This is going to relate to something about radicals. But I want to take a step back in time. Can somebody explain that to me? Anybody, just, I'll take anything. Well, almost anything. Okay, so if the 6 was first, then it would be 6 groups of a half. Okay. So that's beautiful. Not a damn thing wrong with what I just said, because now we know commutativity works, but it's not directly what that means. Well, what's the answer? 3. How does that relate to the 1/2? Half of 6 is 3. So the 1/2, when I multiply, what is that repeated what? Addition. So isn't that multiplication? So it's related to addition. So the 1/2 says, what 2 things add to be 6? What does it take 2 of to make 6 additively? I need this, so let me make sure you guys are with me. If I said 3 times 6, now Drew hit me with it. What does that mean? 3 times 6. 3 groups of 6 added, correct?
Yes.
So it's what you get if you have 3 groups of 6. So the first one says, what do you get when you have half of a group of 6? And another way to look at it is, what does it take 2 of to add to be 6, correct? I need this to make sense. Coefficients are related to repeated addition. So when I have a number in the coefficients, that's related to addition. So this being 1/2 says, what does it take 2 of to make 6? And of course the answer is 3. We've known the answer is 3. Now, can somebody remind me what an exponent is related to? Yes, repeated multiplication. Kick ass, right? So it's related to multiplication. So what does this mean? And you're like, what I just said, Jeff. Well, what does it mean specifically? How would I calculate this if I didn't know what it was? 9 times 9. Oh, you know. So when I have a number in the exponent, that's related to multiplication. So when I have a 2 in the exponent, that says take 2 of the damn things, multiply them together. So what happens when I put a 1/2 in the power? What is that asking? Same idea as this, except it's not addition, it's multiplication. So this meant, what does it take 2 of to make 6 additively? What does this mean? You could do it. You could do it. 3 times 6 was take 3 6s, add. 1/2 times 6 is, what does it take 2 of to make 6 additively? Right? What do you add 2 of to make 6? 9 squared is multiply 2 9s. 9 to the 1/2 is what it takes.
Yes.
What it takes 2 of to multiply to be 9. Yes? I need you to see this. This is such a cool idea. If you guys are with me or not. You guys all cool with 1/2 of 6 being, what does it take 2 of to be 6? That's a very fundamental way of describing what that's asking us. Why is it related to addition? Because multiplication is repeated addition. So a coefficient is related to addition. Exponents are related to multiplication. So if I put a 1/2 in the exponent, it means the same freaking thing this does, except multiplicatively. So what's a different way to write, what does it take 2 of to make 9? Which is what that's telling me. What's a better way to write? What's a way that we're more used to? What does it take 2 of to multiply to be 9? How do we normally write that? No. It's kind of good you said that. Not what does it take 2 of to make 9 additively. That would be 1/2 of 9. Yes? All right. This means, stay with me. This means, what does it take 2 of to add to be 9? This is 4.5. Is that cool? This means, what does it take 2 of to multiply to be 9? Can you just tell me the answer? What does it take 2 of to multiply to be 9? 3. So does somebody have a different way that we already write this? No? I like that. That's how you check your answer. What symbol means, what does it take 2 of to multiply to be 9? Square root. Yes? So I want this to make nothing but sense. All a square root does is cut something in half multiplicatively. So what's another way to write it mathematically? A 1/2 power. Yes? In fact, if you took me for any class above algebra, I have a rant about I wish square roots didn't exist. a fractional power is actually a much better way to write it. You might not agree because you don't see it that way as often. But if we just did it from the beginning, it would be great. Okay, I'll stop. How would I write a cube root then? What kind of power? What's a cube root do something? It cuts it in thirds. So how would I write a cube root as a power? You could do it. Square root of 9 is 9 to the 1/2 because the square root cuts things in half multiplicatively. Cube root of 8, how could I write that in a different way? How would I write that with a fractional power? You just told me. What does a cube root do to something?
Is it 8 over 1/3?
Almost, except you had a word in there that was wrong. Not 8 over 1/3.
8 is 1/3.
8 to the.
2
Okay.
to 1/3.
I got you. These mean the exact same damn thing. A cube root says, what does it take 3 of to make 8 multiplicatively? A 1/3 power says, what does it take 3 of to multiply by this thing? They both mean the same thing. Now, to kind of solidify this a little more in your heads, can anyone remind me, we did exponents a while back. Can anyone remind me what this would be? X squared to the 4th power. What do you do with the powers there? Does anyone remember? Come back. Go away, and then come back. No, yeah.
Do an x squared first.
Well, I can't. I don't know what X squared is. Anyone remember what you do with the powers? You multiply them. 4 groups of 2, right? If I wrote it out, it'd be x squared times x squared times x squared times x squared, 2, 4, 6, 8. So what's the shortcut? You multiply the damn things. You guys all with me? I like it. Therefore, if I have the cube root of 8, does everybody agree I can write that as 8 to the 1/3? If you don't, it's silly because it's right there. Can somebody rewrite 8? 8 is 2 to the what power? 8 is 2 to the 3rd power. You guys all, we're just playing with this shit right now, okay? We're just playing with this shit. I want you to really buy into this more. I want you to see this happen. Is everybody cool with, if I want to, anywhere in the universe I see 8, I can replace it with 2 cubed, because that's frickin' 8. So when I wrote this, I rewrote this. That's all I did. Because what is 8? 2 cubed. And then raising it to the 1/3 power. What do I do with these? Multiply them. What is 3 times 1/3? What do the 3's do? Cancel. So I get 2. And of course, cube root of 8 is 2. We know that from earlier. We did that one earlier, yes? Now listen, I really want you to understand. I'm not saying that this long-ass line of calculations is the better way to do the cube root of 8. I want you to see how a fractional power actually works directly out to be the answer. So if I had a 5th root, how would you rewrite that? If I had a 5th root of something, holy shit, if I had more paper, life would be good. I don't. Do I? Everything's already, okay. If I had a 5th root, how would I rewrite that? You can do it. Square root is a 1/2 power. Cube root is a 1/3 power. 5th root, 1/5 power. Yeah. Okay. Now what if I had 5th root of x squared? What'd you say? No. What am I taking the 5th root of? In what I just wrote, what am I taking the 5th root of? What am I taking the 5th root of? What's inside the 5th root? X squared, yes? How do we do the 5th root of anything? I could rewrite it as a what power? What power? We just did it. What power? Fifth root. The fifth root wants to cut things in how many parts? 5. So fifth root of anything in the universe, I could rewrite it as that thing to the 1/5 power. They mean the same thing. So I'm taking x squared, and I want to cut it into 5 parts, yes? So it'll be x squared to the 1/5. I'm coming up on a shortcut here. What do I do with these two? So I get x to the, don't you dare tell me 10. No cross multiply here, right? I'm not adding. 2/5. Yes. Now, go with me for a moment. Just in case I have any botanists out there. Most plants have roots where? Underneath. Yes. On the bottom. You with me? Most plants have roots on. One semester I said this and somebody in the back went, actually tubers are roots on. Don't be quiet. I'm a geek, I'm allowed to do that shit. What does this have to do with anything, Jeff? I'll get you. What is the root? What is the root here? What am I taking? What kind of root am I taking? 5, fifth root, yes? You agree the root is the 5th, yes? Does everybody see that? This is the 5th root. The root is 5. Where are roots on plants? Bottom. So I put the 5 on the bottom. And the power is powerful goes on the frickin' top. So you can skip all this middle shit. I had to do this middle shit so I could point at this, but now you have a nice shortcut to remember this. So how would I rewrite this? The 11th root of x to the 7th power. Just straight up, how do I rewrite it? Just directly. Yes, roots on the bottom, like most plants. Power's on the top because it's powerful. Those two things mean the exact same thing. How are we doing so far? Have you guys worked with fractional powers ever? Do they make some sense? Damn it. Again, so if you know the square root of 49 is 7, I can ask that same question this way. The only reason this one is not as easy as this is because you're more used to radicals than fractional powers. But again, what's the question this symbol is asking you? What does it take 2 of to make 49? To multiply to be 49. That's why I like this better. Exponents are multiplication. This is half of 49 multiplicatively. So what does it take 2 of to multiply by 49 multiplicatively? That says it much more directly than that dumb thing. You just internalize the question that this symbol is asking you. Equals 7. So, watch what can happen now. You're going to be very excited about this. Can you guys remind me how to do this problem? X squared times x to the 7. Nine, good, right? Not 14. This is where I really freak students out when I say, in this problem, there is no 2. There is no 7. There is no spoon. Yes? There's 2 x's times 7 x's. So of course there's freaking 9 x's. Do you guys see that? If somebody says 2 times 7, I'm like, what the hell are you doing? There is no 2. There is no 7. How do you get 14? There's 2 x's and 7 x's next to that. So of course there's freaking 9 x's. Yes? You guys see that? So some of you, if you thought about it, you know what's happening now. How do you do this? Do I still have like bases? Am I still multiplying? Oh, wait, what are the bases? Somebody said no. What are the bases? X, they both have a base of X. So do I still have like bases? Yes. Am I still multiplying those like bases? Yes. I'm sorry, what does this symbol mean again? Yes. Why don't I use the X symbol to mean multiply right now? Because X means frickin' X, right? So we've gone past that. By the time you're teaching this stuff, you've gone past that. Yes. Do you see how this is the same problem we just did? I just have worse numbers.
Yeah.
So what do you have to do with those fractions? What do you do when you multiply like bases? You add it. So this is something I say to a lot of my math classes. The processes of math don't give the first shit what's in the problem. They don't care. If I have like bases and I multiply them, I add the powers. That's it. That's what math says. Humans, we go, oh man, fractions. But the process doesn't change. I have to add them. And then people, for some reason, they're like, this is hard enough already. I should just be able to make that 3/8. Do you guys see where 3/8 came from? Is that the right way to do that? Does anyone not see where I got 3/8 from? Part of me kind of loves that, if you know, but, right? Just 1 plus 2 over 3 plus 5. Isn't that 3/8? Is that the right way to add fractions? No. Are you guys with me?
Yep.
What I try to get students to understand is the processes of math cannot change. They cannot change. But for us, we have to do different things based on what's in there. Right? So the first problem is easy. I still have to add 2 and 7, but that process is easy. Second one, I still have to add 1/3 and 2/5. That process is a little more complicated because they don't start off as like terms. So I can rewrite this like this, and then I can focus all my attention on the little mini problem up here. Yes? And of course, what do I need to do this? I need, yep, 15, yeah, okay. So multiply this one by 5, multiply this one by 3. You get x to the 5 plus 6 over 15, x to the 11 15s. Crazy. All right. So every property of exponents we learned before continues. It doesn't suddenly change just because it happens to be a fraction. The processes weren't built on that. Still add here. So what am I going to do if I have this? What you got, Jeff? That's a little y down there, by the way. What do I do in this case? Multiply. So now I'm raising something with a power to a power. I'm going to multiply the powers. Dear God, don't do 11 times 28, right? What's the better way to do this? You rewrite it. What happens here? I'm just going to keep doing this. No. Hell no. Good Lord, no. You don't cross multiply. Yeah, cancel out. There's a factor of 11 here. Does this have a factor of 11? Of course. So what do you get when you cancel that out? On here I get 1. Down here I get 3. Factor of 14. Does this have a factor of 14 in it? So I get 1 here and I get 2. So this is y to the 2/3. Wow. This is another reason why I didn't mind skipping 9-1, because I knew that there would be fractions in 9-2 anyway. And I am fundamentally equal, so. Okay. Hi guys, are you guys all right? I know you know the exponent rules. They don't change. It's just, oh crap, I got fractions. Okay. So, the last part of class. Let me make sure I didn't. Yeah, cool. Okay. Last part, last thing, last new idea. Ooh, good. I got it. 3 pieces of paper. Look at me go. Okay. This is not even a new idea. We've been doing this already. But this is where we officially talk about solving equations. Yes? And let me go ahead and give you this handout here. This is a handout that I give to my, or I used to give to my Math 88 or Math 90 class. Oh, that's right. Oh, yeah. Yeah, that one. The one, the colorful one. Oh shit! So to me, the way to introduce solving equations, and this kind of jives with the way I teach how to solve them, is if I start with something like, let's say we know x is 7, yeah? Let's say we just know that x is 7. What do I get if I double x? All right, so what do I get if I add 3 to that? You guys with me? You guys with me? You guys with me?
Yes.
So a long time ago I realized if I kind of start from the end, because I like to teach solving equations, you're trying to unbury the variable. In an equation, your variable's like buried under all this shit. You're trying to subtract 7 and multiply by, you're trying to unbury this poor little dude. So I thought, well, it would make sense just to start with the poor little dude, x is 7, poor little dude. Start to bury him under all this weird math. X is 7, he's all happy, then I double him. Well, and then I add 3 on, oh God. Yeah. So solving equations is taking this and going backwards, of course, right? So therefore, if I start here, I would say, where is my x? Which term has my x in it? This one. So then I see, why is he not alone? Why is this term not alone? No, why is this term not alone? Why is 2x not by itself? Stupid 3. So get rid of him. Because students will tell me, they'll say, why don't I just divide by 2 right now? Can you guys tell me why I don't want to divide by 2 right now? True, so you end up with fractions. And it's not, you could do it that way. Not a damn thing wrong. If you divide everything in there by 2, fine. Why? They'll make fractions show up too early. Exactly. So here I start to unbury my variable. I take the 3 out of there. Now my variable's feeling a little less imposed on, right? And now I can say, why is the x not by itself? Stupid 2. And then I get students that do this. Is everybody with me? That's a mistake. Let me make sure. I thought I was going to misspell mistake, which would have been a hilarious mistake. You guys see the mistake I made? How would you explain to me? I'm the student who did that, and I think everything's great. I'm like, I did exactly what you did. What are you talking about? I got rid of the 2. What do you mean is wrong, teacher? Check that chat GPT. Huh? Why? How do you explain to me why? Like, I subtracted 3. And I'm like, this is the way you do it. I'll subtract 3. And everybody's like, sounds great. So then this poor kid's like, all right, I got you. I don't want the 2. Let me subtract 2.
But you just want that. Because the one was 2x, not 2.
Yeah, but more importantly, why did minus 3 make sense here?
It's just 3 by
Because what's it undoing?
addition.
Addition. So that's the key. You have to undo what's being done, correct? So what's currently being done with 2x? What's the operation between the 2? So what's the opposite of that? There you go. So I always try to tell students, if you're solving an equation, make sure whatever you just did actually cancels something. If you subtract and you had multiplication, that ain't doing shit for you, right? Does that make sense? Okay. So starting over at the last good place, divide by 2, x is 7. That's amazing. Okay. So can you guys, let me see if I can gauge how we're doing. Can you guys do, on the other side here, F and G? Just to kind of go forward a bit. Let's see how we all are with solving equations. This is more complicated, but not too crazy. Just want to see where we are with algebra. Yeah. Here? Or here?
There, but
Here.
down. Or whatever you do. So like, right, yeah.
Okay. And by the way, I am very aware that there could be several of you who have zero issues with solving these kind of equations. I'm equally aware there are some of us who haven't done this in a long time. So that's why I'm going for really basic stuff. So I just want to see where we are with these. So what did somebody do first in part F? Yes, because you say to yourself, which term has the x in it? This one. Why is this term not by itself? This stupid thing. How do I cancel the 6? Subtract 6. That cancels. And what's 11 minus 6? 5. Now this is where I see that mistake, the one I did before, that they add 5. Because the brain says, what's the opposite of -5? +5. And you, hard to argue with that. But it's not the opposite of the number, it's the opposite of the operation. So that is multiplication. So I better frickin' don't. And of course, what would you tell your students to do once they got here? Does anyone know what would you do once you get here? Plug it back in, make sure it works, right? So we plug -1 in. -1 times -5 is +5. 6 plus 5 is 11. Yay! Kick ass. And of course, you're allowed to do that whenever the hell. What's up with part G? What's new in part G? Yeah, I'm being attacked both sides by x's, right? That sounds terrible. So does anyone know what to do in part G? Yeah, so you guys might be very familiar with this in algebra. You kind of pick a side for the x's, pick a side for the numbers, yes? So it's up to you. I always try to keep my x's. No, it's going to be that. I always try to keep my x's positive. Because negative divided by negatives is somewhere that humans can make mistakes, or so I've heard. Humans. So if I subtract 3x, my x's stay positive, yes? It don't matter. You could subtract 8x. It really doesn't matter. Now where do I move what? What's in the wrong place? 11. And you see, this is what I've learned over many years of teaching this level of math, even though I'm not allowed to anymore. And I'll be all right about that. If I say it like that, what is in the wrong place? Number one, a student has to go, what the hell does this guy mean? Wrong place. Oh yeah, x is one side. Oh, what's on the wrong? Oh, the -11 is with the x's. It should be with the numbers. So it's how you frame a problem. And you don't have to frame it the same way I did. It's just the way my brain looks at it. You have to give them a framework, period. The mistake a lot of teachers make is they go, well, that person teaches really well. Let me mimic what they do. That doesn't make any sense. Because the way you teach has to match the way you move through the world. Yes? There's no one person that you want to emulate. No. You have to figure out, who am I? what makes sense to me when we talk about it like that, when we do like that. Yes? I have a very peculiar way of doing things because, weird guy. So I'm going to add 11. And then, of course, you start to notice something. What has the last step almost always been on these problems? Divide. So you almost always divide last. Why? If I divide too early, I could make fractions that I don't need. I don't need fractions in the middle. So let's talk about part I then. And then we'll talk about inequalities, and then we'll be done with the entire semester. Why does problem I, why is it especially irksome? God damn it. So here's the beautiful thing about equations. What's the only thing you're not allowed to multiply or divide both sides of an equation by? You guys know? You can multiply both sides of an equation. I can multiply both sides of this equation by 17.893 if I really felt like it, and mathematically it would be fine. Would it help me? No, so I'm not going to do that. Does anyone, what's the only number I cannot multiply or divide by? You can do it. What's the only number that really messes us up all the time? 0. If I multiply both sides by 0, I get 0 equals 0. If I did that with every equation, we'd be living in caves, right? If I divide by 0, we know that sucks. Let's not do that, because then we make little black holes, and they suck all of us in, and we all live in unity, one compact particle. Let's not do that. What sucks about this equation is the stupid fraction, yes? How do I kill him? Yeah, multiply by 3, yes? What do I multiply by 3? Both sides, not just the piece that needs it. That's the thing a lot of students don't get. They're like, why would I multiply him by 3? Because you don't get to choose. It's a consequence. I want to multiply by 3, don't I? Do you have to, by the way? No, you could subtract x over 3. Most of us don't want to work with fractions if we don't have to. So I multiply both sides by 3. What do I have to do on this side? I have to distribute, correct? It's not a choice I get to make. So what's 3 times x over 3? Let me write it here. Alright, I just rewrote the whole thing. What's 3 times x over 3? Chabow! X. 3 times 1. Holy shit. What's 2x times 3? 6x. Now that looks just like the problem above it, yes? So the great thing about equations, and I try to get students to understand this, is very often, not every time, not all the time, very often you can say to yourself, what do I really not like about this equation? Oh, let me kill it. By the way, not a life lesson. Don't kill things you don't like. My math, you haven't really gotten to see this semester, but when I teach algebra and so forth, it's very violent. There's a lot of death, right? And then I try to remind students, don't become little Dexters and be on the TV going, my math teacher said it was okay to kill my problem. No. But in an equation, I'm like, I don't like that over 3. All right, let me kill him. Why am I allowed to do it? Because I have 2 sides that balance out whatever I do. Yes? If I just saw a 5/3 and I just multiply it by 3, that's not legal. You can't make 5/3 become 5. In an equation, I have 2 sides that balance things out. What do I go from here? What's in the wrong place? Careful, not add x. If I add x, I get 2x. Yes. Whatever you do has to cancel the thing that was there. What do I get over here? Can you guys imagine really quickly what's a very common mistake I see right here? 6. And then I say, and they're like, oh, the x's can't. No, I have 6 of them. I took 1 of them away. So of course there's 5 of them. And then what's the last step? So what's, in most equations, what's the only time I really have to have a fraction? At the end. If I have a fraction earlier, I can kill it. If I have a fraction that shows up at the end, I don't care, because I am done. How are we doing so far? We've solved equations earlier this semester, we have. But nothing too crazy, hopefully. You guys agree, it wasn't too crazy. So last thing I want to talk about, the absolute last idea. The last idea for this semester, be careful, not for your whole life, is how do I solve inequalities? On one level, it's a dumb question. How do I solve an inequality? Same way. And what would I do to solve this? What does that say, by the way? Can somebody read that for me? Greater than 4. So I still get people that kind of confuse the symbols. If it looks like an L that fell over, that's less than. L for less than, if it fell over. L that fell over, that's less than. So that's greater than. You get the alligator and all that kind of crap. Yeah. You with me? You know what I mean? Okay. So here I just add 1, so what's my answer? How many answers did we just get? A lot.
We got more than 2.
Yes, we got a lot. We got every number above 5. How do you represent the answers then? Oh, I see. That's interval notation. That's a little bit beyond what we have to talk about. If I put it on a number line, do you guys remember what to put on the 5?
The arrow.
Good. You make an open circle on the. Why is it an open circle? So where am I going to shade? I'm going to shade all the numbers that actually work, correct? So which way am I going to shade? To the right. And in fact, if your variable's here, that is an arrow pointing you in the direction how you shade. You guys with me? So do I want to shade 5 in? Does 5 answer the inequality? Is 5 bigger than 5? That's why we put an empty circle, because I only shade the answers. Yes? Now some of you guys know interval notation, and then you got the little parenthesis, blah, blah, blah. It's a little bit beyond where I'm going to go. Then you put the shaded in circle, because then you want to include that as part of the answer. Now, the only thing that is different with solving inequalities, does anyone know what it is? All right, let's do it. There is a difference here. What's the first step? Subtract 2, I love it. All your x's are together. The numbers aren't together. So I subtract 2. What do I do next? What's in front of the x? What's understood to be in front of the x? A negative 1 in this case, right? So what do I do when I have a coefficient? What do I do? Divide by. Good. Divide by negative 1. So what's my answer? So I haven't heard the right answer yet. You ready? Which one of these? And real quick, watch this, watch this. Which one of those is bigger? This is kind of silly. Which number is bigger? Okay. Y'all agree? If I multiply or divide both sides by negative, I get this, don't I? Which one's bigger now? So what does sign do? So when I multiply or divide by a negative, the side of 0 it's on changes. The one that was bigger is now smaller. Do you guys see that? Yes? Kick ass. Do you guys get that? This is the closest I can get to just saying, why does it happen? Because it does. When you multiply by negative or divide by negative, it changes the side of 0 you're on. So whatever was bigger is now smaller. So the order changes. So when I divide by a negative, that sign has got to flip. So if I divide or multiply by a negative, the sign has got to flip. Okay, maybe. Okay. I'm a little sad because that's it. That's the end of the semester. What was it? I can't remember. There was somebody. All right, last semester there was somebody who sat right there, and they said something out loud like that. I can't remember what it was, but I wish it was something like that. But she like meant it, and I was like, okay, don't hold it in. But you know, I won't take it too personal. I'm a math teacher. I'm used to people being like, Jeff, you're fine. Everyone's seeing you. This is the practice plan.
Oh, this will be good. Oh, shuckles. I forgot about that. One, two, one.
Did I give you one?
I already got
You got one? Go ahead. Oh. So I'll have an answer key for this on Tuesday. I'll have your quizzes graded Tuesday. I'll have an updated grade sheets Tuesday. Everything Tuesday. Next Thursday is our final. And then you'll be free.
I know.
See you guys.